Hey Seth, did you still remember what we discussed on TLA last week?
Yes, about the report of our classmates about mouse and keyboard.
Oh, we should have our advanced study on the other parts of the computer, right?
Yes.
Let's go on Florence's house.
I'm Rose.
Hi Camila, hi Seth.
Can we have our group study?
Sure, why not? Come on. Just wait, I'll get something on my room.
Hey, Camila! Come here.
Oh, what's that?
Look at this one. This is a hard disk drive.
Seth, can you give me a short introduction about this thing?
All I know that this is a non-volatile and one of the most important part of the computer which help us to save, send, and receive data. How about you?
Oh, I know about of these parts because I searched this at the internet.
Okay. Can you enumerate some?
I know that this is the platter, then this is the spindle, the actuator axis, the actuator arm, and the head. This one is the ribbon cable. Do you know the information about this part?
Actuator is a compact electric motor that moves the red right arm. The red right arm swings red right head back and forth across platter. Central spindles allow platter to rotate at high speed. Magnetic platter stores information in binary form. Plug connections link hard drive to circuit board in personal computer. Red right head is a tiny magnet on the end of red right arm. Circuit board on underside controls the flow of data to and from the platter. The flexible connector carries data from circuit board to red right head and platter. And the small spindle allows red right arm to swing across platter.
Hey, what are you doing?
Oh, we're talking about this.
What do you know about that disk?
I know that the platter is the most important part of that disk. And it can be magnetized or demagnetized. Did you know that it rotates 10,000 per minute?
Oh, really?
Yes. That was very amazing. Two read-write heads in the platter. The one is to read the top surface and the two is to read the bottom surface.
Do you know how does it work?
Let's just watch the video. Bang.
The hard disk drive has 5 main parts. A printed circuit board takes orders from the computer and controls the disk. An electric motor spins the hard drive's disk at exactly 7,200 revolutions per minute. The circuit board keeps the speed constant. And here's the crucial part, the actuator arms that hold the read-write heads. The ends of the arms are split, and right in the middle ride the disk platters. But the heads never actually touch the disks. The space between the head and the surface of the disk is 5,000 times thinner than a human hair. The heads float on a cushion of air created by the spinning disks. An absolutely essential cushion that prevents the head from crashing on the disk. And what a crash it would be. Talking about a crash is not only a metaphor. At these tiny scales, the weight of the heads really compares to the weight of a 747 airplane. A 747 airplane packed with 100,000 passengers flying at 100 kilometers per hour, a fraction of a millimeter from the ground. Ouch. There's no friction to slow things down, so the arms can move the heads to write or access data up to 60 times per second. The engine that drives the arms is invisible because it's an electromagnetic system driven by two forces of nature, electricity and magnetism, which makes the arms move back and forth across the disk at lightning speed. That's it for the components. Now here comes the data. The data is stored inside tiny concentric tracks on the disk's surface. During manufacture, up to 200,000 of these tracks are created on the disk. Each track is divided into sectors. A map of the tracks and sectors in the printed circuit board tells the heads exactly where to read or write information. The surface of the disk is smooth and shiny, but look closer. It's way more complicated. A magnetic film on the surface memorizes all the information. The heads magnetize microscopic sections of the film and store the data in a sequence of ones or zeros. Each one or zero is called a bit. The value of each bit is determined by the orientation of its magnetic field, plus or minus. And it doesn't take long for the bits to add up. One high-quality photo can take up 29 million bits spread across 12 different sectors of the disk. This sounds incredibly massive, but in reality, a stupefying quantity of bits can fit in an extremely small space. Each square centimeter of the disk's surface holds 31 billion bits. Now that's space saving. A hard disk stores and recovers a phenomenal amount of information at speeds that defy comprehension. Using the power of magnetism, the shiny surface of a hard disk can store the contents of several sets of encyclopedias, or hundreds of thousands of images, easy. The hard disk really is an amazing, shrinking machine, squeezing mountains of data into little bites with a single key stroke. This masterpiece of engineering has really stretched the boundaries of physics, bit by bit.
Oh, wow, that was really amazing.
And what will happen to our disk if we would be saving, deleting, copy, and paste our files?
Let's just watch another video.
Does a bigger drive mean a faster computer?
It doesn't necessarily, you cannot say that you have a faster computer if you have a big hard drive disk. Maybe, your computer is affected by malicious software or virus, or you have many programs that you've opened.
Oh, Florence, thank you. I learned more about hard disks.
You're welcome. Bye!
Oh, Flora, I forgot this sa'yo.
Okay.